is equals to 4 and x minus y plus 7 is equals to 0. Can you identify A1, B1, C1 and A2, B2, C2? Just so for this pair of linear equation of two variables, just identify A1, A2, B1, B2 and C1, C2. So what will be A1 in this case? Yes, correct. That is also correct, right? So you must have identified A1, A2, B1, B2. Just tell me the value of C1 and C2. What is C1 here and what is C2 here? Everyone. Shavaz, actually, you guys are not audible to me. I don't know why. There might be a problem with my device. So please write out the solutions.
-4/7.
See, okay. No. In this case, see the value of C1 is incorrect. Shahid. So just remember this. I mean, yes, C1 is -4 and C2 is 7 here. So you have to change 4. You have to take 4 from right hand side to left hand side to get the value of C1 in this format. So A1 here will be 2, the coefficient of x. Then B1 will be coefficient of y, 3. And C1 would be -4, right? And similarly, if I take this, A1 would be, sorry, A2 would be 1, B2 would be -1, and C2 would be 7, right? So that is how we can identify A1, B1, C1, A2, B2, C2. They will be constants. So for every equation, you can see that there are two variables involved. And to solve these two equations, to find out the values of these two variables, we need two equations, right? Now, just a general question. This is not related to our syllabus, but this can be related to your physics or chemistry. So you must have heard about degrees of freedom. If not, then try to identify what does this mean, and try to find out. And I just want to know, this is a general question. You can ask, you can answer in the chat. What happens if I have two variables and three equations? So what am I actually interested in is I want to know the relationship between variables and number of equations. So if number of variables and number of equations are same, they can be solved easily, right? That's it. Shavis, actually, you guys are not audible to me. I don't know why it's happening, but there might be a problem with my device. So everything you want to, if you want to tell me anything, just write it on chat. And before speaking, just raise your hand so that I will wait for your question. Wherever you have any question. Or if you don't have any question and you want to answer, then please answer me. What happens if number of variables is less and number of equations are more? And also, when number of variables are more and number of equations are less. So I can give you an example for this. I'm interested to know what happens in this case, in these two situations. Because we know when number of equations and number of variables are same, then we can find out the solution. You can find out the values of x and y. The example I have given above, you can find the values of x and y in that case, right? So what happens if this situation arises? 2x plus 3y plus 4 is equals to 0. X minus y plus 7 is equals to 0. And x or 2x plus 5y plus 11 is equals to 0. So here you can see that I have given you three equations and number of variables involved are 2. Right? So what happens in this situation? Can we find out the values for x and y? I'm interested in that. My first question. And second question will be, what happened in this situation? Now you can see that in the first case, there were two variables involved and three equations involved. In the second case, three variables and two equations. So number of variables in the first case are less than the number of equations, and in the second case, number of variables are more than number of equations. So can we find out the values of our variables x, y, and or simultaneously x, y, or z in these cases? Or what happens? If someone knows, please, you can put your opinion here.
So,
Okay, you cannot identify the solution. Correct. In which case, Madhya, sorry, I want to tell everyone, please, you guys are not audible to me. So you can just write on the chat your answers. Please give me your answers on the chat. And this is the answer for Sharaz. This is for first part or second part? Also write it. Or both parts. I mean, in both the cases, you will not be able to find out the answer. Or whatever. Okay, cool. And what about Madhya? Madhya was trying to tell something. So please write it in the chat. In the first case, whether we will be able to solve the system or not. And in the second case also, whether we will be able to solve the system or not. Solve the system money, whether we will be able to identify the values of variables. Tariq, if the answer is zero money, if the values, I mean, if you're not able to find out the values of x and y, if the value of x and y is zero, I mean, okay, Austin, if the value of x and y is zero in both the cases, that is a solution. The variables can take the value zero, right? But what we are saying is the system is inconsistent if you do not find any solution. It means that you don't find a value of x. If the value of x is zero, in that case, that is a solution, right? Yes, Madhya is correct. Not possible in both cases is incorrect. We will not be able to find the answer in this case. This is not possible. Yes. Because if the number of variables are less than the number of equations, the system will not be able to solve. You will not be able to solve the system. Shahid, we can use elimination method. Okay, if you want to use elimination method, you can use it, but you will not be able to find out the values of x, y, and z separately. You can try that. Okay, if we apply elimination, then we have to subtract them. If we subtract them, we got minus 3y plus 6z is equals to 7. Now see, we have one equation and two variables. So we will not be able to identify the solution still, right? So in the second case, when number of variables are less and number of variables are more and number of equations are less, it is not possible to solve the system. So to solve any system of linear equations, you should have at least as many equations as the number of variables. Now, in the first case, let's come to the first case. Yes, we will be able to find out the solution, but it is not, I mean, we are not sure about whether the system is consistent or inconsistent, but definitely we will be able to solve them. Now, what do I mean by system is consistent or inconsistent? Let's understand this. So if I give you these three equations, and if I ask you what is the values of x and y, so that, so that the given system is consistent. So if we are saying that the given system is consistent, it means that if I say this, that I'm not saying this is a consistent or inconsistent, but if I say a system is consistent, I mean that the values of the variables are satisfying all the conditions. So we should have, if I say that this system is consistent, it means that one value of x and corresponding value of y will satisfy all three equations. if we say that the given system is consistent, it means that whatever variables are involved in all those equations, right? All the variables should take some value for every equation to satisfy. So if I say this is consistent, it means that one value of x and one value of y should be there, which should satisfy this as well as this as well as this. Right? Now I can solve them taking in a pair. I can solve them taking in a pair. What do I mean? That I can take these first two equations and find out the value of x and y. Some value of x and some value of y will come. So okay, I'm going to solve. I'm actually writing them directly. This is first system. Okay. And then this is second system. And then the third one is this. First and third one equation here. Right. So the first system, I'm writing the values directly. Okay, I have to solve this. X is -5 and y is 2. Yes, x is -5 and y is 2. The answer of first system. Okay. Now the second one. I mean subsystem. I should not call it system. System is all those three equations combined. But this is a subsystem of the greater system. Right. So x minus y plus 7 and 2x plus 5y plus 11. This will give me the answer. Y is 3 by 7 and x will be minus 46 by 7. Now you can check. You don't need to check for the answer of x and y for third subsystem. You can tell from here on that there is no solution to all those equations. The first part is giving you the solution. X is equals to -5 and y is equals to 2. And the second part is telling you that x is equals to minus 46 by 7 and y is equals to 3 by 7 is solving them simultaneously. If the value of x would have been -5 or y is equals to 2, in that case, मैं बोल सकता था the system is consistent because the values of x and y are same for all three. But in this case, no, this system is not consistent, inconsistent. But definitely we can solve them, and there may be a situation in which a value of x and y will satisfy all the three equations, right? So in these cases, when the number of variables are less and number of equations are more, you can definitely solve them, but you have to check whether a solution exists for all those equations or not. But in the cases when variables are more and equations are less, right, it means that you can't solve that system. Don't waste your energy to solve that system. You will need at least, I'm going to write this actually, you will need at least as many equations as the number of variables involved in the given system. So this is an important point. To solve a system of linear equation. Now this might help you in physics and chemistry because there's a term called degree of freedom, which is directly associated to whatever we have just understood. Degrees of freedom basically tells you whether you will be able to solve this or not. And that is how you calculate degrees of freedom. To solve a system of linear equations, we should have at least as many equations we should have at least as many equations involved in the system as the number of variables minimum number of equations should be equal to the number of variables involved in the system. Okay. Now, after this, so we know now when can we say that the given system is consistent? If they have a solution, then they are consistent. If they don't have a solution, they are said to be inconsistent, right? Now, anyone remembers cross multiplication formula? Just raise your hand if you remember or not. I don't want to hear it. Do you remember that? Nobody remembers that. Actually, I also don't remember that. That is the point. See, in 10th class, we were tuned to accustomed to learn some formulae and then apply them over the questions directly. There is no indirect information given. All the information will be given to you directly. You will have to just use the formula, right, and find out the answer. But that wasn't a good process. So instead of that, what we are doing is we have formed a method known as Kramer's rule. This method is known as Kramer's rule as well. That's just a minute. I'll have to check your syllabus once. I don't know whether Kramer's rule is there or not. There are Okay, Kramer's rule is not there, but Kramer's rule is far more easy than the inverse method, but it's okay. So there is a rule, there is a rule, Kramer's rule, which can give you that cross multiplication wala formula directly. But as we don't have this, so we don't need to understand this. Rather than this, we will learn how to solve system of linear equations. So we already know how to solve a system of linear equation in two variables or pair of linear equation in two variables. Now the new thing is we will have three linear equations and three variables now, and we will try to solve this system of linear equation, right? Now it can be solved using two methods. The first one is, which is in our syllabus as well. So there are two rules. First is by using matrix inverse method or adjoint. And the second one is also known as matrix method. This is also known as matrix method. Yes, so there are two methods to solve this. First is by using a matrix inverse method or matrix method. And second is Kramer's rule, which is basically your determinant method. This is far more easy than the first one, but this is not included in our syllabus. So we'll have to go through matrix method only. Now, why did I say this is easy? Because it is easy to calculate the value of a determinant. So in this, we just have to solve some determinants and we can find out the value directly. And it is comparatively difficult to find out the inverse of a matrix. It's not that difficult, but still, to find out an inverse of the matrix is difficult then to find out the value for determinant. That is why I said that the first method is a difficult one, but it's also easy, not very easy. So let's understand what inverse is. Let's understand what do we mean by matrix method. So we'll be given a system of linear equations first of all, and we'll be identifying some of the values. Okay. Let's do this. Now we will be given a system. So a given system of linear equations in 3 variables should be consider a1x plus b1y plus c1z is equals to d1. So let's understand the variables first. X, y, and z will be our variable. We can use any 3 variables, right? And all the other things will be constant here. So a1, b1, c1 are basically the coefficients of x, y, and z respectively, and d1 will be your constant term, right? And you will always write it in this way. So a1x plus b1y plus c1z is equals to d1. One side will be all the variables, and the right hand side will be your all the constants involved. Second equation can be a2x plus b2y plus c2z is equals to d2, and a3x plus b3y plus c3z is equals to d3. Okay. Now also understand these 3 are constant terms. So one example can be 2x plus 3y minus z is equals to 4, x minus y plus 2z or 2z is equals to 7, and then 3x minus 4y plus 6z is equals to 2. Right? So this can be an example of system of linear equations in 3 variables. Right? Now also understand, if these constant parts are 0, all these constant parts are 0, then this equation, the same equation, like 2x plus 3y minus z is equals to 0, x minus y plus 2z is equals to 0, 3x minus 4y plus 6z is equals to 0. It means that if all the constant parts are 0, then we will call that system as homogeneous system of linear equations. Right? Right now, this is non-homogeneous. Homogeneous means everything is same. All the constant part is same basically. Non-homogeneous system of equations. Linear equations, obviously. And if d1 is equals to d2 is equals to d3 is equals to 0, then the given system is said to be homogeneous. Given system of linear equation is said to be homogeneous if all the constant part is 0, right? So we can have either non-homogeneous system of linear equation, or we can have homogeneous system of equation. Homogeneous system of linear equation is easier to solve comparative to non-homogeneous system, but most of the times we will only get non-homogeneous system of equations. But the idea is same. We just have the calculation is less in this case, homogeneous, but the idea is same. The method concept is same. Okay, so A1, B1, C1, D1, A2, B2, C2, D2, A3, B3, C3, D3. They will be basically constants. Like in this case, in this given example, A1 is 2, B1 is 3, C1 is -1, and D1 is 4. Then A2 is 1, A3 is 3, B2 is -1, B3 is -4, C2 is 2, C3 is 6, D2 is 7, D3 is 2. Right? That is how we can identify this. And like also, if we need to transform something, so let's say if this is given, x minus y plus 2z minus 7 is equals to 0. In that case, I will transform this. I will take the constant part, that is -7, to the right hand side. And then I will write out the values of A1, B1, C1, D1, A2, B2, C2, D2, A3, B3, C3, D3. But it is very essential. It is a critical step that you identify A1, B1, C1, D1, A2, B2, C2, all the constants, all the coefficients, as well as constant part correctly. Okay. Because the solution starts from here. So this given system of linear equation, or in fact, any given system of linear equation using n variables, and for those n variables, we should have n equations, right? So if there is a n cross n system of linear equation, n variables and n equations, so that n cross n system of linear equation can be solved using matrix. Now, how to solve this? So first of all, this system, the given system, can be written like this. Given system can be written like AX is equals to B in matrix form. I'll tell you what is A, X, and B here. But before that, this system, whole system, can be written as AX is equals to B. Now, understand some terms here. I'm calling this A as coefficient matrix. These are not technical names. These are my given names. You understand it like this. But always remember that A is your coefficient matrix and X is your variable matrix. So you can also A, B, A, X, and B. So we do know that X is generally a notation of variable, right? That is why we have written X here. That is the only thing. That is the only reason why we have written X here. Because you guys are more susceptible to understand X as a variable, right? So X here is a variable matrix. A and B are constant, right? Similarly, we take every time we took A and B, the notation is just for constant, right? So A and B are constant like this, constant like things here, right? And X is a variable. Okay. Now we have to find X. How will we find X? We will talk it about in a bit. But before that, we should understand what is A and what is B and what is X as well. So A is a coefficient matrix. A will be formed using all the coefficients. So A1, B1, C1, A2, B2, C2, A3, B3, C3 are all the coefficient of your variable terms, right? And D1, D2, D3 are all the constant terms here. I mean, A1, B1, C1 will also be constant, but they will be known as coefficients of X, Y, Z. But D1, D2, D3 is not a coefficient of any variable. They are independent. They are some constants, right? Like in the previous case, 4, 7, and 2 were the constant. Okay, I'm removing this. I'm writing it again like this. So AX is equals to B is a matrix form of the given system of linear equation only. Now, how do we identify that? How can we write it like this? First, my first question should be this. Okay, I'll tell you. But first, identify what is A, X, and B. So A is your coefficient matrix. You know there are 9 coefficients involved, right? So this matrix should be 3 cross 3. Just write out the matrix directly. So A1, B1, C1, A2, B2, C2, A3, B3, C3. Take all of the coefficients, form a matrix, and you can easily see that this why I am calling this as a coefficient matrix, right? Then, as I said, X is a variable matrix. Okay, the order is 3 cross 3, right? Now understand, I have multiplied A and X here. You know, when can you multiply 2 matrices? To multiply 2 matrices, the number of columns in first matrix should be equal to the number of rows in second matrix. So I don't know the order of X, but I do know there should be 3 rows in X to multiply A and X, right? So this will be 3 rows money. This will be a column matrix actually. Column matrix of X, Y, Z. Column matrix of your all the variables. So the order would be 3 cross 1. X is your variable matrix. We want to find X. So basically we want to find out the values of X, Y, and Z, which is our main goal. Actually, if you see, we are writing the system of linear equation. We want to find the values of X, Y, and Z, which satisfies all these 3 equations. Right? That is our goal. So we have to identify this matrix X, which is a column matrix of all the variables. Now, what is B? B is again, you can identify what is the order of B, because the order of A is given, order of X is given. So order of A into X will be 3 cross 1, right? So B will also be a column matrix, D1, D2, D3 of your constant part. You have A. If you have a system of linear equation, so you basically have A, you have B, you have to find out X. That is our goal. Okay. Now, before we reach to how are we solving this, I want everyone to form A, X, and B here in this example. The main thing is to form A, X, and B. So please try to identify how to form A, X, and B. What should be the first row of A? You can write in the chat, what should be the first row of A? In this example. So A is your coefficient matrix. Correct. Good, Faiza. What should be the second row? First row is correct. First should be the X coefficient, 2, then 3, then -1. What should be the second row of this matrix? A. We are trying to make A, X, and B from the given example. You know what is A? A is a coefficient matrix. Correct. Very good. 1, -1, and 2. So this should be 1, -1, and 2. What should be the third row? 3, -4, and 6. This will be your A coefficient matrix. Now what will be X? X is same for everyone. Don't worry about X. X is X, Y, and Z only, right? And then B would be a column matrix of 4, 7, and 2. We have to find out the value of X. We have A, we have B. So this is our goal. A problem can be first break down into forming the right A, X, and B. If you're forming the right A, X, and B, then everything you know about everything. All the steps, I mean, you don't know the steps yet, but you know about the operations that we are going to apply on this. So you have to basically find out the matrix, inverse matrix of A, and then multiply it with B to get the value of X. Let's solve this system of equation. So first of all, if you multiply A and X, just please multiply A and X. So we'll take first row here. To multiply A and X, we will take first row. We will multiply this first row with first column, right? And we'll equate this to B. A into X is equals to B. Let's multiply A and X. So first row with first column, it should be A1 into X plus B1 into Y plus C1 into Z. First row with first column, there is no second column and third column. So this will be the first element. First row with first column, then second row with first column. This would become A2X plus B2Y plus C2Z. And then third row with first column, this will become A3X plus B3Y plus C3Z. And we are equating this multiplication of A into X with B. B was D1, D2, D3. Now, if you solve this, you know when two matrices are equal, their corresponding elements are equal. So first element should be equal to D1, then second should be equal to D2, third should be equal to D3. You can see that if you solve this AX is equals to B system, you are basically getting the three equations only, above three equations from where you started. So first question should be, how did we reach to AX is equals to B? Because this is just simple matrix multiplication. We are choosing the A, X, and B correctly. If we do that, we will be able to form the equations again. Right? Okay. Now the second part is, how do we find X? We have defined the system. You have told us that how to write this system in the form of matrix. Now, how to solve this? Now, apply your matrix concept to solve this equation. So I'm actually writing out the method AX is equals to B. How did we reach to our solution? What do we need to do? So what I'm doing is I'm multiplying, I'm pre-multiplying. Now pre-multiplying and post-multiplying, these are two important things. Pre-multiplication meaning we are multiplying it first. We are taking that thing first. Post-multiplication meaning we are taking that thing in the last. So pre-multiplying with A inverse in LHS and RHS. I'm basically multiplying this whole equation with A inverse, but I'm pre-multiplying it, which means I will write it like this. A inverse, first I will take A inverse, then I will take the whole left-hand side. Similarly, first I will take A inverse and then I will take the whole right-hand side. If I was post multiplying it, in that case, I will write AX first and then I will multiply that AX with A inverse. Right? So that is post multiplication. But we are right now doing pre-multiplication. And why did we do pre-multiplication? You will understand this. Now this A inverse and A will become I. You know the property of inverse. If you multiply the inverse with the matrix itself, you will get I. So A inverse into A combine, you can combine this and take X. Right? And here you can write this as A inverse B, multiplication of A inverse and B. Right? This A inverse A will become I, and this X will remain same. This is A inverse and this is B. Multiplication of I with anything is the same matrix. So basically, the value of X can be found out as you first find out the inverse of A and then take that inverse, multiply it with B. Whatever you get is the answer for X. Right? Please feel free to ask me your questions. I'm explaining it again, but you guys feel free to write out all the problems or doubts which you have. Till then, just understand it once more. We are taking A first. I'm simplifying the algorithm. So we will take the system. Then I'll form my A, X, and B. X will be same for everyone. Only A and B will change, right? And then I'll take that A. I'll find out its inverse. I'll first form A, X, and B. Find out inverse of A. Multiply A inverse with B to reach to your final solution. These are our steps. So I can basically write this in an algorithmic form as well. First step should be identify A and B. You already know about X. Find out A inverse. No, no, Shahid. We cannot, because why are we saying this? We have explained this in the first class. I mean, in the initial classes of matrices. There is no concept of division in matrices. See, there is no concept of division in division. So if you are taking A directly to the right hand side, you are basically saying that B by A. But that doesn't exist in matrix. Matrix can only perform three mathematical operations, either addition or subtraction or multiplication. All three have some conditions. You cannot multiply any two matrix or you cannot add any two matrix. They have their specific conditions, but you can only perform these three mathematical operations. Right? Okay. So find out A inverse. So whenever you want to take, whenever you want to do these things now, then you have to either pre-multiply or post-multiply with inverse. Always remember this. You may have some equations also. There might be a 1-marker question in which you have to solve some equation, matrix equation. So always avoid division matrix. Instead of division, use the multiplication with inverse. Multiplication with inverse works as the division only. Okay. Okay, so find out A inverse. And then X is equals to A inverse B is the given solution. Here is the required solution. There are 3 steps involved. Yeah. So the important part is this one. You will be able to identify A and B. This will only take 1 or 2 questions. You'll be able to identify easily A and B. But the main part is to solve this correctly. Solve this part correctly. If you find out A inverse, if you miscalculated something, then you will not be able to find out the solution. And always check. My point, this is my suggestion. My suggestion. What? Always check the solution. To check the solution, just put your values of x, y, and z in the given equation. Okay, whether the equation is satisfying or not. For first 5 questions, you will have to do this. Then only you will get better. So this is a calculative part. Let's solve a pair of linear. Let's solve a system of linear equation first. You can also solve a pair of linear equation through this method, by the way. चलिए करते हैं equation. Wait. Yeah. Yes. Let's solve some questions. So we also have, we have some more things in the method, but before that, let's solve some of the questions and be thorough with our work. What do we want to achieve? So a question might be, let's solve this system of linear equation, example 28. Okay, so this is given. Solve the following system of linear equations by matrix method. Okay? And let's not take this question as well. Let's take a question from the exercise one. Okay. Let's solve this one. 12th, x minus y plus z is equals to 4. x minus y plus z is equals to 4. Then 2x plus y minus 3z. 2x plus y minus 3z is equals to 0. And then x plus y plus z is equals to 2. Right. So in this case, we have A. A is the coefficient matrix. So it should be 1, minus 1, and 1. 2, 1, and minus 3. And then 1, 1, 1. Right. We also have x, x, y, z. And we also have B. B is 4, 0, 2. You can see that the second element is 0, but it will still be called as non-homogeneous only. If they ask you what's the name of the system, whether it is homogeneous or non-homogeneous, then it is still non-homogeneous because two values are non-zero. If all the values are 0, then the system will be known as homogeneous. And if at least one value is non-zero, then the system will be called as non-homogeneous or heterogeneous, right? So to solve Ax is equals to B, now we know the above system. We should have actually written this in this system can be written as Ax is equals to B, where A is this, X is this, and B is this, right? Now we know to find X, use X is equals to A inverse. So first, the critical step is to find out A inverse, right? Let's find out A inverse first. Then we will talk it about what are the other situations also. So to find out A inverse, we need to know about its adjoint, right? And the value of its determinant. Now, my question is it possible to find out inverse in every case? Will we be able to find out inverse? I mean, we do know the formula, but it will not be possible to find out inverse in every case, right? In some of the cases, this determinant of A can be 0. If the determinant of A is 0, it means that inverse does not exist. Now, if inverse does not exist, how do we find out the solution? Whether a solution exists or not. So that is the remaining part. But we will not get much questions on this. That is why I did not got into that part first. So first understand, we will be able to find out inverse in almost all the cases. Almost all the cases. Okay. We will be able to find out inverse in this case as well. To find that out, first find det. Det means determinant of A, which will be 1, minus 1, 1. 2, 1, minus 3. Then 1, 1, 1. Right? And to also, this would be 1 into 1, 1 plus 3, 4. The value of determinant is 10 in this case, right? So if it implies that determinant of A is equals to 10, which means A inverse exists. So as I said, in almost all the cases, you will be able to find out the inverse. That is, determinant will not be 0. That is the main task, to find out the X. So in almost all the cases, X will exist. And you can find that X using A inverse. You can find that A inverse using adjoint and determinant, right? So first, I identified whether the inverse exists or not, right? So I know inverse exists. Now, to identify adjoint, I will find out C1, C2, C3, C4. I mean C11, C12, C13, then C21, C22, C23, and I do know what is C11. So I have to find out the cofactors basically. C11 is the cofactor of 1. this element, right? So C11 would be minus 1 to the power I plus j, which is 2 in this case. I plus j is 1 plus 1. Then delete the row and delete the column. It would be 1 minus 3 would be 4. The answer is 4. I am writing the other values directly. So this would be minus 5. C13 would be 1. Then C21 would be 2. C22 would be. You guys also check, please. Everybody, everyone solve this with me. Because it might be possible that I'm wrong. So everybody has to check. And a greater possibility exists that you will be wrong. So please, everyone check. So these are the cofactors. So adjoint of A will be the transpose of this matrix. And the transpose of this matrix would be 4, 2, 2, minus 5, 0, and 5. This is the second row. And this will be third row. 1, minus 2, and 3. This will be the adjoint. So I know determinant of A. I know the adjoint of A. So I do know the value of A inverse now. So the A inverse will be 1 by 10, 4, 2, 2, minus 5, 0, 5, 1, minus 2, 3. And the solution of the system can we find out using X is equals to A inverse and B. You have A, you have A inverse, you have B, you can find out the solution. So X would be equals to 1 by 10 into A inverse would be 4, 2, 2, minus 5, 0, 5, 1, minus 2, 3. Please, everyone check this, whether I am correct or not. Has someone solved it? Okay, we will get to know about this after the solution, but if you would have done this, this would be better. Okay, so B would be 402. So then you have to multiply first row with first column, right? So this would be 1 by 10. Now the order of this is 3 cross 3. This is 3 cross 1. So you know the final, whatever the product is, that have 3 cross 1, right? So there will be a column matrix only. Okay, first row with first column, 4, 4, 16, plus 2 into 2, 4. 16 plus 4 is 20. Then second row with first column. There is only one column, right? So second row with the column, minus 20, plus 10, minus 10. Then the third row with the column, so this will be 4, plus 6, 10. Now, before even checking the solution, I have a feeling, in fact, I have a greater confidence that we are correct. Why? Because this 1 by 10 can go inside and this can easily divide these three numbers. And we got a solution which looks like a solution. So this X would be, if we take 10 inside, so this would become 2, minus 1, and 1. And we know what is X. This was X, Y, and Z, right? So you can say that the value of x is 2, the value of y is -1, and the value of z is equals to 1 is the solution of given system of linear equations. And now after this point, I will go and put these 2, -1, and 1 in this original equation. So I got 2, -1, and 1. I will put these 3 here. In the first part, 2 plus 1. This is -1, and this is also minus. So 2 plus 1 plus 1. 4. 4 is equals to 4. Yes, that is true for the first case. If it is true for the first case, I know it will be true for every case. Okay, let's check third one as well. 2 -1 plus 1. -1 plus 1 gets cancelled out. 2 is equals to 2. Correct. If you put it here, this is also true. 4 -1 -3. 4 -4 0. Yes, it is satisfying all the 3 conditions. So after getting my answer, I will check. Every time I will check whether the given solution is satisfying the equations or not. Because this is check. This we can check, right? We do have a checkpoint for this. So this question involves 6 marks. This used to come in 6 marks before. I'll identify what is the paper, what is the exam pattern for this year, but I'll tell you. But this will be the highest marks question from these chapters. You have to solve a system of linear equation. It can come either directly, they can either directly give you these equations, or they can form a word problem over it, and you have to form the equations from those word problems, and then you have to solve it. But definitely, you will be solving a system of linear equation in the CBSE board paper. This is unavoidable. I mean, this has to come. This is certain, quite certain. They have been giving this for the past 15, 20 years. So, and continuously. So we have to solve a system of linear equations. To solve that system, we have to identify A and B. Then we have to identify, and then we have to find out A inverse. And then we can find out the solution using x is equals to A inverse B. This is the process you have to go through, right? But this is not the only process you have to go through. Why? Because there might be a case when we are not able to find out A inverse. No. What if A inverse does not exist? So first of all, in most of the cases in our syllabus, we will not face this problem. Let's write it here. In most of the cases in our syllabus, A inverse will definitely exist, right? But what if A inverse does not exist? Then we will have to go through the equation again. So we do know that x is equals to A inverse B is the solution, right? But we are saying that A inverse does not exist. X is equals to A inverse B is the solution. But this does not exist, right? Now, the reason for non-existence of this A inverse is the value of the determinant. So what I'm doing is, I'm just writing this in this form. Can I write it like this? Adjoint of A divided by determinant of A. This is also correct, right? A inverse can be written in the form of adjoint of A divided by determinant of A into B. And the problem is this determinant. This determinant becomes 0. That is why A inverse does not exist. Now we will not be able to find out the A inverse definitely. That is true. But what about the solution? Do we have a solution? Yes, we may have a solution or we may not have a solution. But how to identify that will be a trick, very easy trick. So all of you have studied limits in the 11th class, right? And in limits, you have heard about this kind of problem. So if you put x is equals to 5 in this case, you get 25 minus 25, which is 0. And then 5 minus 5, which is again 0. So if you put x is equals to 5 in x square minus 25 upon x minus 5, you get a 0 by 0 form. This was known as, if you do not remember, I would like to revise this, indeterminate form. It cannot be determined directly. But do we say that there is no solution for this? Or can we get a value? Yes, we can get a value if we factorize this x minus 5 into x plus 5 divided by x minus 5. Cancel out x minus 5, x minus 5. So this becomes x plus 5. Now you put x is equals to 5, you get value 10, which is the value of this expression actually. At x is equals to 5, the value of this expression is 10, not 0 by 0. Because there is no such term 0 by 0. It has no meaning, in fact, 0 by 0. Right? So in limits, we heard about the concept 0 upon 0 form. And we know that 0 upon 0 form has some answer, has some value. It can be solved using limits, but it has some answer. That is the same concept which we will apply here. Right? Now, understand the whole algorithm. Okay, I'm just removing this part. X square minus 25 upon x minus 5, the part of limit. I'm removing it. I've revised it just for a simple concept so that you can remember this easily to make a trick for this. Okay. So what if a determinant of A is equals to 0? So two situations arise when either determinant of A is 0 or determinant of A is not 0, right? So when determinant of A is 0, A inverse does not exist. So first, let me take the first case first. If determinant of A is not 0. Guys, we have already solved this in the first question. The first question was this only, in which determinant of A was not 0. This will be our most general case, 97% question. Out of 100, 97 questions will be this. In will not be 0. A inverse will exist. So in all such cases, when determinant of A is not equal to 0, you will get a value of x. Definitely get a value of x. Because you have A inverse, you have B. You will multiply them, you will get a value. So in all such cases, when determinant of A is not equal to 0, we have a unique solution. And that solution can be found out using this equation. If determinant of A is not equal to 0, then we will have unique solution, and that solution will be given using this equation. What if determinant is 0? If determinant is 0, first of all, A inverse does not exist. So in place of A inverse, we have written this adjoint of A divided by determinant of A. If that A is 0, then we have 0 in the denominator. Now we will check what is our numerator. So this gives us two cases. You will have to check adjoint of A into B. If this whole multiplication, that is the multiplication of adjoint A with B, multiplication of adjoint A with B, this whole multiplication you will have to find out. If this is also 0, then you get a 0 by 0 form, right? And I just told you the concept. If there is a 0 by 0 form, then there will be some answer for x. 0 by 0 form is not, 0 by 0 will have some answer to it, right? So if this is 0 by 0 form, it means that if adjoint of A into B is equals to 0, then it will have solutions, infinitely many solutions. We do know that there are only three cases. Either they will have unique solution, or they will have no solution, or they will have infinitely many solutions. Unique solution when determinant of A is not equal to 0. It means that you have A inverse and X can be found out using A inverse B. There will be only one value, right? But in the second case, when determinant of A is 0, we will have to go for this numerator part. If this numerator part is 0, then 0 by 0 answer is infinitely many solutions. If this multiplication is not equals to 0, then imagine this. This is some multiplication. This will have some value. Let's say the value is some value. Some matrix will be the value actually. There will be some matrix, multiplication of both of these, and then there will be 0 in the denominator. There is a part of numerator. I mean, numerator is non-zero, denominator is 0. What's the answer? Not defined, right? We have been doing this for the whole life. Not defined. Whenever we get denominator 0 and numerator has some value. So let's say 4 by 0. 4 by 0 is not defined, infinity, or not defined, right? So similarly, if adjoint of A into B is non-zero, then no solution, not defined. Similar to the concept of not defined. We don't know about this. No solution. No. Right? So if determinant of A is not equal to 0, then this will be the easiest case. I mean, easiest, not easiest, actually. It will be the most calculative case. Because you have to find out the whole solution. You'll have to find out the A inverse, and you'll have to find out the whole solution. But if determinant of A is 0, then you will go for this part, adjoint of A into B. If that is also 0, then 0 by 0 form, there must be a solution. The only solution case exists is infinitely many solution. If this multiplication is non-zero, then non-zero upon 0 is not defined. Not defined means no solution. Simple. You can remember this in this form. यार जितने भी लोग हिंदी समझ सकते हैं उनको मैं और इजीली इसको एक्सप्लेन करना चाहूंगा कि बहुत इजी है. सबसे पहले डिटरमिनेंट ऑफ ए, यू हैव टू कैलकुलेट डिटरमिनेंट ऑफ ए. इफ दैट इज नॉन जीरो तो कोई पॉइंट ही नहीं है. ए इनवर्स निकलेगा ही निकलेगा. ए इनवर्स निकलेगा, कोई ना कोई सॉल्यूशन बनेगा ही बनेगा, और एक ही बनेगा. दो बन ही नहीं सकते. ये भी सोचो, एक ही बनेगा सिर्फ. मतलब आप ए इनवर्स को मल्टीप्लाई करोगे बी से, देयर विल बी ओनली वन वैल्यू यू विल गेट, राइट? And you can solve the question directly, जो कि हमने किया first part. And if determinant of A is not 0, then the problem arises. Then you will check for the value of adjoint of A into B. अगर adjoint of A into B का value O आ जाता है, O आएगा ये actually, not 0. Because this is a matrix, right? This is a matrix. भाई ये भी matrix है adjoint of A, और B भी एक matrix है. So after multiplying adjoint of A with B, we will get another matrix. If that matrix is O माने zero matrix, null matrix. If that matrix is null matrix, then we get 0 by 0 form. और 0 by 0 form माने यार solution है कुछ ना कुछ. इसका कुछ ना कुछ आंसर आएगा. आंसर आएगा. आंसर में हमारे पास एक ही बचा है अभी, infinitely many solution. आंसर दो तरीके से मिल सकते थे. You got two ways to get an answer, either unique solution or infinitely many solution. Unique solution वाला case already हो चुका है. It has happened already. So we will go for infinitely many solution. जब 0 by 0 होगा. अगर नॉन 0 by 0 है, it means like this 4 by 0, है ना? तो this is not defined. Not defined माने no solution. That is how we can identify whether a given system has unique solution or infinitely many solution or no solution. These two cases you won't have to check these two cases first of all, and बहुत ही कम cases में you will have to go for it. Otherwise, in most of the cases, determinant of A will be non-zero only. This is the original question actually. Actually, we want to find out X. There should be some X which exist. So the goal is to find X. This is not the goal. This is actually deviating from the goal. So that is why they have less cases. Okay. Please feel free to ask your problems first. Then only I will assign some of the work. Please feel free to ask your questions. Just raise your hand if you do not understand anything. If you do not understand any explanation or what to do in this case, or you got any other questions, please, I'm all ears. The class is over for now. I mean, you don't have to leave the class, but we are not teaching any new concept. We are done with all matrices and determinants. This was the last topic actually. Okay. In that case, I mean, you can still ask the question. Don't worry. I'm just telling you things what I want to discuss. This was the last topic, and in this, I think more than to solve a given system directly, solve some word problems also. That will be tough. Otherwise, to solve out this system will take you 3 questions. If you solve 3 questions correctly, you are good with it. I'm not saying you just have to solve 3 questions. I'm saying that after 3 questions, it will be easier for you to solve the question. You find out the things directly. Charlie. So you have to solve 4.6. Whole exercise 4.6. Now let's come to is this some question from this first 6 questions. Examine the consistency of the system of equations. Examine the consistency of given system. They are saying, right? So to examine the given system, I would like to first state the rule. If you want to identify whether a given system is consistent or inconsistent, consistency, yeah, inconsistency. So first of all, this case, Hanji, what is this case? Unique solution. Is this consistent or inconsistent? Is this consistent or inconsistent? When determinant of A is not equal to 0, it means you got unique solution. What do we call this system when we get a unique solution? Is it consistent or inconsistent? Answer. Yes, consistent, right? So, and what is this case? Infinitely many solutions. Consistent, inconsistent. Consistent, right? And the third one is inconsistent. So whenever we get a solution, either it's one solution or infinitely many solutions, the system is said to be consistent. And whenever I do not have a solution for the given system, then I will say that this system is inconsistent, right? So to know whether a given system is consistent or inconsistent, we don't need to solve the whole system. We can identify this using some simple steps. So first step is find that A. If determinant of A, find determinant of A, right? If determinant of A is not equal to 0, if determinant of A is not equal to 0, the given system will be consistent. No, with unique solution. If determinant of A is not equal to 0, तब तो काम ही आसान हो गया बहुत. Then it is easy. Determinant is not equal to 0, सीधा बोलो consistent. Unique solution. If determinant of A is equals to 0, then we will go for adjoint of A into B. So if adjoint of A into B is also 0, then we will say 0 by 0 form. Yani ke consistent. There is a solution. Which solution? Infinitely many solutions. And if this is non-zero, then non-zero upon 0 will be inconsistent. So to solve, to examine, whether a given system is consistent or inconsistent. Find out determinant of A. If determinant of A is 0, if determinant of A is non-zero, you are done. The given system is consistent. If determinant of A is 0, then you will have to also find out first adjoint of A, then the multiplication of adjoint of A with B. If that is 0, consistent, that is non-zero, inconsistent. Right? That is how we can solve the question. So you'll have to solve 4.6 whole exercise from the NCERT. We will take your problems in the next class. Okay, guys, I will not be available tomorrow, actually. Someone might be, some other teacher might be taking my class. I don't know about that, but you will be informed appropriately, whatever happens. So I'll not be taking the class in the tomorrow as well as in the next week. Actually, I have a family function. So not just family function, we are going out somewhere as well. So some plans. But I'll be joining from, I guess, in the last week of the May. But you'll have your classes in between. So we are done with matrices and determinants. Whoever is going to take the next 3 classes, you can tell them to start with inverse trigonometric functions. You can start with inverse trigonometric functions. Then we can also, I'll take relations and functions, because inverse trigonometric functions is actually shortest chapter among all 3. So all the other chapters. So that is why I said that. And also the relations and functions, we'll be using that in the calculus part as well. So I want to take that portion because I'll be needing that portion again and again. So I want to complete that portion according to this. Okay, Shali, give everyone please appear for the test, and we are done with the class. Okay, solve exercise 4.6, the next class homework. Okay, all of this exercise 4.6 is your